本岛第一个结合太液电池的太阳能智慧型微电网社区，每个用户建置3000瓦太阳能发电及太阳能热水器、9度电锂铁电池，并设置一个高达100度电储能电池与电力调度控制中心，利用太阳能电力进行充电。小型储能充饱后，多余电力送往集中型储能进行电力储存。若区域发生灾变，该社区则成为紧急电力供应中心。近年来，碳排放量有增无减，燃煤和燃油燃烧会产生大量的温室气体，对环境造成的污染也特别严重。所谓碳交易，就是把以二氧化碳为代表的温室气体视作商品，通过给予特定企业合法排放权利，让二氧化碳实现自由交易的市场。如果一家企业排放量超过能源部门分配的配额标准，就需要花钱从其他企业手中购买配额。反之，如果企业通过节能减排等技术减少了排放，就可把手中富余的配额出售，由此带来收益。碳交易市场的启动，对清洁能源也意义重大，将调动企业对清洁电力的积极性，推动清洁能源发电占比不断提升，最终实现清洁能源对传统能源的全面替代。绿电凭证能够证明使用100%的绿电，同时具有加速再生能源的功能。另外，此券上并会标示产出的时间、地点、制造者资讯与减排环境贡献。使用此券不仅能对环境能源提升的贡献之外，亦能于企业社会责任报告书上宣告，提升企业形象与成为国际荣誉标杆。为了落实全球能源自主减碳及抑制不实资讯散播与双重交易，透过区块链技术结合能源应用，解决繁琐验证和交易资讯，并提高凭证交易速度与资安保障，提供再生能源市场更好应用未来。
Once logged in, the SciTime Event Manager software will open to the system screen. The system page allows for quick status updates on any previously identified SERs connected to the network. To see how to load SERs in the Device Manager, see the first video in this series. Once you get to the system screen, the overall health of the system is listed above. Right to the right of that, you have a refresh button where you can refresh the information. And just to the right of that, you have the auto refresh button. If you click that, it will automatically refresh every 30 seconds. On the system screen, a simple color code indicator will alert the user to SER status. Status indicators are as follows: error, warning, normal, event today if you've had an event in this calendar day, and event hour if you've had an event in the last hour. Each SER that is identified by the Event Manager will be displayed on the system page as a graphical block. SER identification will be by name if one has been assigned, and IP address of that device. There are 4 buttons associated with each SER's graphical block. By clicking on the name, or by clicking on the last comms icon, it brings up basic information about the SER connected to the network. When selecting the Last Event button, the user is directed toward the Embedded Events web. When selecting the I/O status button of an SER, visit our website or refer to SER Instruction Bulletin for operating instructions. For the Events page, click on the Events tab. The Events page offers a look at the past events for all SERs located on the network. The user can select the items viewed per page. You can also select pages by the left and right arrows. On the Events page, you have the ability to view the event log from all connected devices. The Events data screen shows the date of event and time of event. Device name, if you've named the device, IP address of the device, the channel the SER is on, the event type, the status of that particular SER, time quality, sequence of events, and delta time. You can also export a CSV file to your computer by clicking the Export button. Also, the page refreshes every 30 seconds on its own, but if you want to refresh it, go ahead and hit the refresh button whenever you'd like to. You also have the ability to filter the data here. You can select the calendar parameters, beginning and ending here. You can also select by device name or the IP address. You can also select by the event type. Also, you can select by the status of the device and also time quality. So remember to always hit apply after you've made changes, or you can hit the default button to default back to the beginning. And that's an overview of the events page on the SciTime Event Manager. For more information on the Event Manager software or to view our other Event Manager videos, visit us at www.cyber-sciences.com. The I/O Status tab shows the current I/O status of each connected SER on the network. The Status tab shows the state of the unit per input channel in the graphical interface. Status indicators show on, off, inverted, and forced settings of each channel per each SER device on the network. The 2 different types of SERs are 32 input channel SERs with no outputs, such as an SER 3200, and 24 input channel SERs with 8 output channels, such as an SER 2408. As you can see, the 8 output channels on the SER 2408 are highlighted with a distinguishable white dotted line around them. In this example here, SER with the IP address 192.168.2.41 is showing on channel 1. The SER 192.168.2.43 is showing on channel 8, and it is showing on and inverted on channel 1. On that same SER, you can see at output channel 1, there's a small e. This represents an error state. This may be due to improper wiring. Like other pages on the Event Manager, you can export files to your computer. You can also refresh, and you can filter the search. The filter settings adjust search parameters for the I/O status data. You can view the content by user-adjusted parameters or by default settings. The user can filter by unit IP address, model number, or assigned name. And finally, let's take a look at the diagnostics page. Here you have reporting from all SCRs on the network, their diagnostic status. You have the ability to sort by device name, IP address, catalog. You can also see the hardware and firmware version, time source setup, time source actual, time quality, PTP state, PTP key, and diagnostics. Just like other pages, you have the ability to export a CSV file. You can also refresh the page at any time. You have a filter setting where you can select the device by IP address or by its name. You can also select the catalog number. You can select time quality. You can also select by the time source setup of the SCR and the time source actual that the SCR is on. And finally, PTP port state. Remember to hit apply anytime you've made a change. Let's run through a scenario here on the diagnostics page. UPS-1C, which has an IP address of 192.168.243, is showing an error state on their diagnostics. Let's run over to the Systems tab and look up that SCR. Let's click the Diagnostics tab.
We will be covering our vertigo installation of our system. Welcome! Today we're going to walk through an installation of a vertigo system into a panel board. We'll see that it's easy to install and manage and allows you to see granular data about your building. The first component of our system is the Vertigo Smart CT. It has a digital data cable that comes out of it to record the sensor measurements. Each one also has a socket that you can plug the cable into. There's a flexible hinge on the back where you take out the tab and you pull it back to release the clamping mechanism. When installing, you want to open the clamp, put it around a wire, and close. And once you hear that snap, it's closed and you're ready to measure energy. The install kit that you receive from Vertigo will include the correct number of sensors for the panel that you're installing on. The next component of our system is the generic interface module. You would utilize this module for connecting to loads beyond what our Smart CT can handle, generally loads about 90 amps and above. This module utilizes the same data interconnect and the same data socket, so it can daisy chain along with the Smart CTs or other generic interface modules in your system. There are 3 sensor ports that will take the positive and negative leads from your off-the-shelf CT. There is a magnetic backing on it that will attach to the panel board. And when you seat the CTs in, don't forget to put the darker wire in the black socket and the lighter wire in the gray socket. This component of our system is our base transmitter. It's composed of 2 main sections, the main transmitter data collector and the field wiring compartment. The field wiring compartment is where we will route wires through into the panel through this conduit hole. The base transmitter consists of 2 data ports that connect to our sensors, as well as 4 voltage ports that will connect to the 3 phases of your power panel plus the neutral line. It will both sense voltage off these and power the system. The system is designed for 480 volt Y connections. Be sure that you do not put 480 volts across neutral and any other phase because that is beyond the specifications of the system. We like to mount it on the side of the panel, left or right side, and be sure when you mount it, there's a slide-out compartment on the bottom which has diagnostic lights, that the diagnostic lights are visible. Obviously, if it's pointed to the panel, you won't be able to see the diagnostic lights. When installing on the panel, we select where we want the transmitter to be attached to. Make sure you have clearance of 5.5 inches by 5.5 inches deep by 15.5 inches tall, wherever along the side you're installing the panel. If there's an obstruction on the panel that prevents you from having that distance, you may place the transmitter on the opposite side. Okay. When your panel's open, some panels will vary in color. Ours have red, black, and blue primarily. They will alternate in color to indicate different phases. For this installation, we've identified our optimal location for our transmitter, and we've created a 1-inch knockout in the panel to establish a connection through which we will have our transmitter get sensor data. Take the field wiring compartment off of the top of it, and we can go ahead and pop off this top too, so we can work within our base transmitter. And we will want to align the knockout on the field wiring compartment with the knockout of the panel. We've provided a chase nipple and lock nut to attach the field wiring compartment to the panel. And then we will take our lock nut and attach the system to the panel. Once your field wiring compartment is firmly attached, we're ready to do our voltage taps. We want to make sure that our colors for our wires match the phases in the panel. And we're going to pick 3 spare breakers, 1 of each power phase, to connect our voltage taps to. We want to be sure to de-energize the breakers before we work on them so that we're safe. So first we're going to take our black wire. We're going to seat it into the breaker at the end. And after it's seated, we are going to tighten. Right? Then we will take our red wire, feed it in just below that, on the next phase down. And finally take our last power phase, blue, feed it into the third breaker of the third phase. After all the voltage phases are connected, we'll take our new voltage taps and we will feed them through the knockout that we just created and leave them here for us to connect to our base transmitter later on. And finally, we'll connect our neutral tap. We pick an open port on a neutral bus, thread our wire through, then with a screwdriver. Now we're going to run our neutral line through the knockout again and bring it down just with all of our other voltage taps. When installing your current transformer, you open the clamp, you find the circuit that you want to attach to, and you go in, put the clamp around the circuit, and snap it shut. And you repeat that for each current transformer you would like to install. In this particular panel, we have very, very thin breakers. In cases where the space is required, you'll see it's better to stagger the current transformers so that they fit. In places where you have a little more space, the current transformers can be stacked one on top of each other. After all your current transformers are clamped around the wires, you will take the output of the topmost sensor and feed it into the sensor beneath it. And the sensors will daisy chain so that all the information passes through this sensor chain back to the transmitter unit. Now you can see we have a gap between our sensors. Your installation kit will include a variety of extension cables that you can use to bridge these gaps if you don't require sensors in between. Don't forget to listen to the click when you seat your cables to ensure the data is properly flowing through your sensors. In some cases, you'll be doing an entire panel, so you want to make sure that each sensor clicks in and your data flows through the entire column of the panel. When we installed on this side, we had our load facing this way, so our wire goes out this way. If we're installing on the other side of the panel, we want our current to still flow in the direction of the load. So we will install our CTs in this direction on this side of the panel. If you require current sensors greater than 90 amps, you can use our generic interface module. To install it, pick a location along the panel that's convenient to seat the wires from. In this case, I'm going to put my generic interface module right here along the side of the panel. The data cable will connect directly to the smart CT. In your kit, if your panel has larger loads, you'll have one of two types of off-the-shelf CTs. One is an AccuEnergy split core current transformer. There's a tab on the side that you pry open, and there's a hinge, and your current goes through this clamp. There is an indicator on this that is an arrow. This arrow also goes in the direction of the current, so be sure that this arrow goes the same direction as the load, and the label here goes towards the source of the current when installing. Our system is also compatible with an AccuEnergy Rogowski coil. The coil opens by pushing these two tabs in to unlock these clasps, and the coil opens this way. Many people prefer this because it's flexible and can fit in tight spaces. The Rogowski coil is good for any load above 600 amps, up to almost 20,000 amps. When installing the coil also has a designated arrow that shows the direction of the current. So you want to make sure that current is flowing this way through the coil when installed. When connecting an off-the-shelf CT to the generic interface module, you'll select one port for each CT. Make sure the darker wire of the connection goes into the darker socket, and the lighter wire goes into the lighter socket. For the purposes of the Rogowski coil, there's a shielding wire that you do not need to connect. Your kit will include extension cords of varying length, 1 meter and 3 meter. So we'll connect the socket on the first CT on the chain, bring it over the top of the panel, and then feed it through our knockout that we've created. Likewise, we'll take the second extension cable, connect it to the last CT on the chain here, and you'll notice I'm using now the female socket on the male connector on the bottom of the chain. Bring it along the bottom of the panel, and also feed that through our field wiring compartment. So now we're going to connect our transmitter. First, we're going to connect the voltage cables. On the transmitter, there are 4 voltage taps, and you can see them labeled neutral, A, B, and C. We're going to take our voltage wires and connect them appropriately to each connection. So be sure that neutral goes into the neutral port. It's very important that we not expose the system to higher voltages than we would like for this port. Next, we connect in order from the panel. So black is my A port, red is my B port, and blue is my C port. Once the voltage cables are connected, it's time to connect our data lines. In panels where you have the left and right side of your panel populated, you'll want the left side to be in port 1 and the right side to be in port 2. In this case, I'm only connecting one side of my panel, so I'm going to just put it in port number 2. After your system is connected, you want to bring the excess slack that you have back into the panel. The system will click in to the field wiring compartment, and we will want to take our top unit and connect it onto the system. Don't forget to make sure that the diagnostic port is visible from the front side of the panel. We will put the end cap back on and thread the screws through. And you'll use a 3mm hex to tighten the top screws. Once the butt is secured onto the panel, we can power on the phases that activate it so that we can boot up the system. On startup, the CTs on your chain will begin rapidly blinking. That's an indication that they're running their self-test. As long as all the CT lights shut off, the system has passed its check and it's ready to go. So after your CTs go through their self-check, you'll want to see this chain light go green. And once this light goes solid green, that ensures that the chain is physically connected. If this light goes red, you'll want to check the continuity of your chain, and we'll look at the light code for that in a second. You can see in this run, the chain light has turned green, so our chain is continuous. The next light we expect to turn on is the voltage light, and the voltage light will go solid based on the color of the indicated voltage. We won't worry about the top light yet because that's related to the commissioning, and that's going to happen at a later process. So once we have a solid light on voltage, the physical installation for the panel is complete. The next stage of our process is that we will go through the commissioning process. Once your system is connected and powered on, it'll emit a wireless hotspot that you can connect to. Open any mobile device or laptop and look for a Wi-Fi network that says vertigo dash and the serial number of your system. In this case, we've installed system 10001308. I'm going to connect to that system. And see, I'm connected. Sometimes your mobile device will switch over to your mobile network instead of the hotspot. And just to avoid that, we're going to turn off our mobile data right now. You can also do this by going into airplane mode. So once you're connected to the hotspot, open any web browser and go to your favorite URL. In this case, mine is vertigo.co. The hotspot will navigate you to the commissioning page of our system. In the configuration page, you'll see a splash screen that asks you to select the region. I'm in the United States, so I'll select that, and I'm going to begin configuration. The first thing we do is we enter the panel name. In this case, I'm running through this demo for you, so I'm going to call my panel demo. The next stage is to assign the cable colors of your panel. In this case, I am black, red, blue, so I'm going to leave those colors as is. For special options such as voltage override and powered by single phase, please refer to your system manual, as those specialty configurations are covered in that manual. The next step is to assign my voltage taps. So at the top of my bud, there were connections A, B, and C. And I connected them in a very specific order, and I connected tap A to a black wire, tap B to a red wire, and tap C to a blue wire, and those were the 3 phases of my panel. So I'll tell the system that that's how they're connected right now. And now my system has auto-detected the types of current transformers that are connected. In this case, on my chain 2, I have 6 vertigrous CTs. I'm going to identify the first CT and enter its name. In this case, it's an office receptacle, and I will call it office receptacle 1. I will choose a cable color that it's attached to. In this case, it was attached to a black phase, and I'm going to hit next. Now for the second CT, it's on the same 3-phase breaker as my first one, so I'm going to say it's on the same breaker. You'll see office receptacle 1 is automatically copied in, and I'll select the cable color, basically the phase of that circuit, which is red, and hit next. For my third CT, also same, but this time blue. Now I'm on another bank of CTs. So in this case, this will be my chiller pump. So I'm going to call this pump 1. And it's also connected to a black phase. Likewise, this is the same phase. It's pump 2. And finally, same phase connected to blue, and I'm going to complete my connections. In this final summary, you'll see a summary of the connections that you made so that you can review them once to make sure that they're connected the way you expect them to be. When you're on the screen to configure the CT, to identify which CT you're on, the CT that you're currently commissioning will begin to flash, and all the other ones will remain dark. So now I know that this CT on this chain is this first one coming out of the bud, which is right here. As I progress towards the second CT in the chain, the second CT will light up. So there's an indication to say what you're actually labeling and commissioning is what's physical CT that corresponds to. Next in the commissioning process, we'll want to upload a photo of the panel just to remind ourselves how the installation was. That way, if we make any mistakes during commissioning, we can go back and refer to the photo and see what we might have done. So in this case, I'm going to open my camera app. I'm going to take a picture of my installation. I'm going to hit OK. And it has a photo to upload, and I'm going to save it with my commissioning data. Lastly, you'll want to connect your data to you want to connect your data connectivity to your base transmitter unit. In this case, our unit is equipped with both Wi-Fi and 4G. But for the purposes of this demonstration, I'm going to walk you through the Wi-Fi connection. If you have an LTE connection, all you really need to do is hit LTE and it'll connect. In Wi-Fi configuration, you'll see a list of potential access points to which you can connect. In this case, I know my local data network is vertigo test Wi-Fi, so I'll enter that. I will put in the password to that, and this is our office Wi-Fi, so I'm going to type it in a little bit more discreetly. Once you have the password saved in, you submit that, and the system will utilize the credentials that you provided it to attempt to connect to that same Wi-Fi network. Once that's done, it will come back with a confirmation. It could take a few minutes to connect, but once it does, it'll come back and say, this Wi-Fi network is okay. When commissioning a generic interface module, the screen will be a little bit different than what is shown on the CT module. You'll still enter in the circuit name. So in this case, I'm going to call this a chiller. You put in the cable color. It's really important to note which port of the generic interface module you're on, because the phase association is very important for making sure the power calculations are correct. Because the generic interface module takes many different sizes of current transformers, you can select what size of CT you use from the array that we provide. And there's a particular option for Rogowski coil because the Rogowski coil power calculation is done differently than the split core ferrite. So in this case, we're not using Rogowski coil, so I'm going to leave that option off. And then you repeat the steps for the next phases, making sure that the current transformer that this port is connected to the correct color phase. And it will likely be the same size CT that you're using for each of these ports of the gym. So I'm going to call this chiller again and hit next. And then this is also the same breaker, and it's also 200 amp. You can see when you select it as the same breaker, it'll autofill the name and the size of the CT. Once your system is properly configured, you'll see a solid green light for the CT chain, a solid green or white light for the voltage connection. The color will be different depending on the type of voltage that it senses, and a solid green light for the Wi-Fi connection. If all three of these lights are solid green or white, this top indicator will show white and your system is transmitting. If this is ever red, that indicates that one of the subsystems is not properly configured, and you may open this to see what it is. And again, if your Wi-Fi light is red, typically the system is having trouble connecting to either the LTE connection or the Wi-Fi present near the panel. You can go through the commissioning process again and just go through the connect Wi-Fi option to try to see if you can reconnect it to that Wi-Fi, but perhaps your internal network Wi-Fi might be down. For the voltage check, if your voltage chain, if the voltage detected is not reading the right phases or reading the right levels, there's a chance that you've maybe connected the phases of the voltage incorrectly, and that would be something to check if this light turns red. That means it's not a compatible voltage configuration that the system is detecting. And lastly, the CT, if this shows red, then go to the CT lights to see where the break in the chain might be. But if the light is red, the system is unable to see a continuous chain back to the base transmitter. But if all three lights are good, then your system is up and running and you're all set for granular data that leads to actionable insights for your building. So let's introduce a fault and see how we can detect it with the system. In this case, we've missed one connection. During the self-check of the CT, you'll see that each CT will perform its quick flash diagnostic as normal. But you'll notice the first few CTs in the chain will extinguish their light as if they've passed, and at some point, these CTs remain lit. The change from good status to error status indicates approximately where the fault is. In this case, it's obvious, and we've missed this cable connection. Another thing to check during installation is that all of your load arrows are pointed in the right direction. So the circuit breaker feeds energy out to its load. You can see all of our CTs are marked so that the load is pointed in the same direction as the circuit. If you're using off-the-shelf CTs, you'll want to just double check that the load arrow is going with the circuit if you were to have used this system.